I'm good.
Good.
Yeah.
So has the math been going any better?
It has, yeah.
Good. I felt like you were making progress.
Mm-hmm.
All right, let's look at these. Let me think for a moment.
Okay.
Our overall strategy is going to be what here?
To define if, like, it's infinitely many solutions, one solution, or no solution.
Well, what I meant really was our strategy should be to figure out which set of lines we're looking at. In other words, I can figure out which equation is that, and I can figure out what equation is that, what the graph looks like, and figure out whether that is A, B, C, or D.
Okay.
Then I can proceed to choose whether there's one solution or infinitely many. Notice that I can pick that out from the graph. That's one solution.
Okay. Yeah.
That's no solution.
Is that no solution?
Hold on a moment. Let's
Okay.
see. That's infinitely many, and that's no solution.
Yeah.
That's one solution. Now, think for a second. Is that no solution, two parallel lines? Because y would have...
If they're parallel lines, then they're no solution because they never intersect.
Right. Right, for sure. Yeah, no, you're absolutely right. I don't know what I was thinking about. Okay, so it looks like what you've done, or what you started to do here, is to solve that for y.
Yeah.
And then you would know which line that is. So you get y equals minus 2x plus 4, right?
Yep.
Which line goes through the coordinate y equal 4? In other words, which line on this whole page, there's only one.
Yeah, B.
Yeah.
Okay.
It's the only one that goes through that point there.
Yeah.
And notice that this equation here is precisely twice, or minus 2 times that equation. That's all it is. It's the same equation, and therefore it has the same line.
Yeah.
You see where if we were doing simultaneous equations here and trying to solve this, we would multiply this one by minus 2, right?
Yeah.
And then we would add, and we would get the same thing, 0 equals 0. So we wouldn't solve for anything.
Okay.
Okay, so over here, we know that y equals x. Well, there's only one line on the graph that's true. This line right here is y equals x. So right off the get-go, this has to be C.
Yeah, because, like you said, y equals x.
Not D. Yeah.
Yeah.
In other words, if I move the y to the other side, I got y equal x gives me a slope of 1, and it goes through the 0 point. Goes through the origin. The y-intercept is 0.
Okay.
It has to be that one. In fact, that's the only line that goes through the origin. Okay. And just one moment. Match the system, then determine whether it has one. So it doesn't actually want you to solve these. In other words, the moment we see that there's only one line that matches that, we know it's 2 is C.
Yeah.
And we can look at C and see that there's one solution. It's right there. So we don't have to do anything with this second equation. We can ignore it. Okay? Now let's look at number 3. If we do the same strategy, what do we get? 4y equals...
4y equals negative 1 plus 2. Or vice versa.
That line is
negative.
that line isn't on there. What in the world?
Yeah, that's what I was like.
That's a horizontal line.
Yeah.
I don't see any horizontal lines on there.
No.
If we solve that equation, hold on a moment.
Okay.
This is a bit strange. I don't know
Yeah.
if it's a typo or what, but if I solve that equation, I get 4y equal 3. So y equal 3/4. And if I graph y equal 3/4, that is a horizontal line going through the point 3/4. And I don't see that anywhere.
Me neither.
Well, let's look at the, I bet this is a typo.
Yeah, I bet it is.
That's an X.
Yeah, she's done that before.
You left off the X. Yeah, notice every other equation is X and Y.
Yeah.
So let's pretend that that's an X. And now what? Now we get, that'll impress her. Make up what she meant for it to be.
Yeah.
Okay, so move the X over. So you got 4y equal 2x plus 1. Y equal 1/2 x plus 1/4. Is that line on there?
Let's see.
We need a slope of 1/2, and we need it to go through the quarter point.
Yeah, D.
There's the quarter point, and that's the right slope.
Yeah.
I think that's the right slope. It looks like it goes close to 1/2. It's hard to tell exactly because it doesn't cross any intersection points.
Yeah, exactly.
But that certainly looks like 1/2. And
Yeah.
this one, if we solve it, we get, excuse me, I'm pointing at the wrong one, over here, we're going to also get a slope of 1/2.
Yes.
Notice that if I move the 6y on the other side, forget about the 9 for the moment, if I move the 6y on the other side and divide by 6, we get the coefficient of the x term as 3/6, which is 1/2. So both of these have a slope of 1/2 if we presume she meant to put an x there, and clearly she did.
Yeah.
So that has to be D. And that, we can tell, has no solution because they don't ever cross.
Yeah.
And now that leaves this one. We figured, we said 1 was B, right?
Yeah.
And we said
So 1 was
C.
B, 2, and then 3D, 4A.
Yeah, 4 has to be A. But let's examine the slope. The slope on the, if I move the 3y over, then the slope has to be 1/3.
Yeah.
And that looks like a 1/3 slope. It's flatter than that one over there. So for sure, that's a 1/3 slope right there. And in fact, there's an intersection point, and there's an intersection point. I got to go up 2 and over 6.
Yeah.
So that definitely, that line has a slope of 1/3. So clearly that A and 4 go together.
Yeah. Okay.
And as far as the one solution, infinitely many, and no solution, you can actually pick those from the graphs. So once you've matched up the graph with the equations, that follows.
Yeah.
And you've got that right.
Okay. Yeah.
He's right. All right.
Yeah. Cool.
All right. Let's see.
Okay.
Determine whether the system has one, none, or infinitely many. Well, let's see here.
Okay.
Trying to arrange my things so I got room to see your answer. have 5x minus 5y equals 5. So we would have infinitely many if the second equation was a perfect multiple of the first. Is it?
It's not, no.
No, it isn't. It looks like it is on the left. It's minus 5 times the first. But this is 5 times that, not minus 5. So if I applied our magic here, multiplied that by 5, that by 5, and that by 5, and now add the two equations, I get 0 equals 10. Whenever you get 0,
which isn't true.
And whenever you get two numbers equal to one another that aren't equal, then you know that you have no solution.
Yeah.
Okay.
Cool.
Let's look at this second one here. Okay. It's just as easy for me to go through it from the start as it is to try to figure out
it is, yeah.
your work. But
yeah.
Okay, so really probably the best way to determine the answer here, well, I don't know. I kind of do like the method of seeing if one is a multiple of the other. Is that true here?
Let's see. No, well...
No, it isn't. Well, this is a multiple of 2 over the bottom.
Yeah.
This is a multiple of minus 2, and this is a multiple of minus 2.
Yeah, so it'd just be one solution.
Well, we should be able to solve this.
Yeah.
Well, let's multiply the bottom by 2. 2, 2 minus 4. Now let's add the 2. What do we get?
Yeah.
What do we get when we add those two?
So you get 4x plus y.
No, the y's disappear.
Or so yeah, plus 0. Equals 0.
Okay, so what's x equal to?
X is equal to 0.
Okay, and now if x is 0, well no, x can be 0, y would have to be minus 2.
Yeah.
Now let's test that on the first equation and see if that's correct. 2 times 0 minus 2 times minus 2 is equal to 4.
Yeah, so that'd be one solution.
That is one solution, exactly.
Cool.
In other words, we can solve that.
Yeah.
That's all you need to really do to figure out whether it's one or none or infinitely many is if you can solve it, you know you got one.
Yeah.
And they try to trick you on all of these, make it look like one is a perfect multiple of the other. And again, this is twice that, and this is minus twice that. So we don't have that going on.
Yeah.
So let's try to solve it.
Okay.
What would you do?
So you would... So 4 plus 8, which is so 12x minus 3y.
Hold on, yeah. Now, if you're going to solve it, let's try to solve it by elimination.
Oh, okay. So you can multiply the top one by 2.
Okay. When we do that, we get 8x plus 6y equals 54. Now what?
Okay, so now the x, so you can subtract the x values, so it'd 0 out, and so would the y values.
Well, now hold on. You can't subtract and add at the same time.
No.
In other words, it's true that if I subtract these two equations, the x is going to disappear.
Yeah.
But if I add the two equations, the y will disappear. So this is kind of unique in that I can make either variable disappear that I want.
Yeah.
But I can't do both addition and subtraction in the same step.
No.
I'm going to suggest let's add the two equations because
that's
I know that'll disappear if I add the two equations. So if I add them, what do I get?
So you get 16x plus 0 equals 30, yeah. And then x is equal to 2.
Well, not quite. X is equal to
16.
30 divided by 16, which is not 2. But,
Or 30 divided by 16, yeah.
yeah.
Oh, yeah.
But, let's see, it doesn't really ask you to solve it.
No.
It just says, tell you whether it has one solution, infinitely many, or not. Well, once you've solved for X, you know it has one solution.
Okay, yeah.
You don't even have to solve for Y.
No.
And
Okay.
it's good because it's going to be hard to solve for Y because X is this oddball fraction. X is going to be 15 divided by 8. Who wants to do that arithmetic?
Yeah.
Although it wouldn't be that bad. The 8s would cancel. But the fact is that if they don't ask you to solve it, don't go to the effort of solving for Y. Once you've solved for X, you know it has one solution. Infinitely many. Let's talk about that because we didn't get one here that was infinitely many.
Okay.
Now, this one had one. Well, how would you get infinitely many? If I had the following. That all by itself is infinitely many. So if I add another one that is merely a multiple of that, then I still have infinitely many.
Yeah.
I haven't added anything new.
No.
What happens if I tried to solve this system? Well, I'd multiply the top by 2, everything, and then I would subtract equations, and I get 0 equals 0.
Which is infinitely many.
Right. That's how you can tell when you go to solve it. If you can't solve it, we couldn't. And in fact, the only difference is if you can solve for X, you have one solution. If you get 0 equals 0, you have infinitely many, and if you get 0 equals a number, you have none.
Okay, so if it's
That's
like...
in a nutshell.
Yeah. So if it's like 4 is equal to 4, that'd be infinitely many. Or like...
If it was what?
If it was like 4 is equal to 4, that'd be infinitely many.
Yeah. Yes.
Okay. Cool.
All right. This modeling problem here. Let's take a look at that.
Yeah.
So, let's draw a little picture of this.
Okay.
Let me think for a second. Six miles per hour is a slope. That's what slope would be. In other words, if we had miles up there and we had hours along the horizontal axis, and I said I was going 6 miles per hour, well, that would be, you would go from, that's what you would do. You would go 6 miles in 1 hour, correct? Okay.
Yeah.
So, let's graph that, just like that.
Okay.
That's the slope and the picture of one of the teams. Well, let's call that Team B. And I'll tell you why in a second. Because Team B has a slope of 6 miles per hour. Well, Team A also has a slope of 6 miles per hour. But they started 2 miles ahead.
Yeah.
Which means their graph is parallel to that one, but started 2 miles higher up on the y-axis. Since these lines are parallel, will they ever cross?
No.
So Team B will never catch up to Team A.
No.
Because for it to catch up, it would have to have a faster speed. Notice that A started with a 2-mile head start. Well, if B was going 7 miles per hour, it would have a slope that looks like that. And it would eventually cross with A, and that crossing point would be the point where B caught up to A.
Yeah.
But the fact that B starts at 0 and A started with a 2-mile head start. So now let's come up with the equations. So we've drawn our picture. Give me the equation for team A.
Would it be y equals 6x plus 2?
Yes.
Cool.
What's the equation for team B?
Y equals 6x.
Very good.
Cool.
That is a little bit of a tricky problem, though. Definitely is a tricky problem. The key is kind of figuring out that you got to draw the picture on this. You have to have a horizontal axis in hours and a vertical axis in miles. And then you realize that if you're going 6 miles per hour, that's a slope of 6.
Cool.
All right, we got a few minutes here. If you don't have anything else, let me test you on your math.
Okay.
Okay?
Sure.
Not that I necessarily think you need it. I don't. But it's always good to drill every now and then.
It is, yeah.
So give me these as quickly as you can.
Okay, 1. -5. -11.
It's kind of fun once you get good at it, huh?
It is. -9. Or +9.
No, you were right the first time.
Or -9, yeah. Because it'd be -2.
Okay.
1. -11.
How are you so good at these? Have you been practicing?
I have -9.
Good.
Yeah, we've.
I
Cool.
tell you what, math is so much easier if you're good at this.
It is. -1. -8.
Yeah. That's impressive, Dylan.
And -2.
Perfect. Class over. I don't need to do this anymore. Wow, I'm really impressed. You've upgraded your arithmetic skills by like 100%.
Cool.
Yeah. Terrific. Well, you deserve to get out a little early tonight.
Okay. Thank you.
You're welcome. I'll talk to you next time.
All right. Sounds good.
Bye.
Thank you.